Right, welcome everybody. Today's stream is going to be what you could consider an AFK stream, where it's just going to be running whilst I do a little dev work on this one. I want to see, for one, if they can keep up streaming directly to Twitch, and two, it's a thermal test to see if it's, when it's getting powered by the USB hub, if it overheats, and it being the iPhone 15 Pro. Also, let's hope that this mic is active. On the other apps I can see a audio meter coming off the interface, but on this app it doesn't show any audio meters, so I don't actually know if it's this or the internal microphone. When we have a chatter or two that can confirm, we can do some testing walking away from the camera and see if the audio affects. Hi Lars. Well, now you get to be my guinea pig. Is this the microphone? Did I manage to mute the microphone? I clicked the button. Did I mute it? I realized I should have asked, like, before I clicked the button, if it now became muted. But I mean, you ought to have heard that it stopped, the mic shut off, right? That would be the best. And well, let's see if it overheats or not. I'm optimistic. Lars, I have a thing I would really like a 0.2 millimeter soldering iron for. How do I show scale easiest? By an electrical wire. And those are here. Okay, come on. Okay. Use banana for scale, that'd be nice. Okay, this is American wire gauge 14. This is 18. And this is 22. 22, which is the thinnest one I have, can take, like 100 watts or something, like more than I actually need, but whatever, it's quite powerful. And this is a single strand of red wire. And this is the back of the board. And I guess we can switch camera and use front, so it's a little sharper. I say sharper, but it doesn't want to focus. Okay, if we use the, then we get macro and we can zoom. There we go. Okay, so this is the USB-C input. And it has that lovely black circuit on it, which is a voltage regulator that can do 4 to 24 volts in and make 5 volts out of it. It doesn't have any inputs for running a wire to it. So I would have to solder to one of the pins, and you can see how small they are. But I have managed to find, let me get a poking device. I have managed to find a test pad. Let's see if I can zoom in on it. There we go. There. You see that little circle? That is gold. That is a test pad that is a part of the input, the positive input. And I wish to solder to it. And this is my wire. And you can see how big the wire is compared to the pad. This is the 22, mind you. This is the smallest of my wires. for scale, this is a 14. Yeah. And for scale, let's see. This is my smallest soldering iron. Let's see if I can get it in here. So, I mean, I think it could be doable, honestly. Not that I think, I mean, that looks absolutely doable. I thought that would look absolutely impossible, but it kind of could work. And this is the soldering iron you use most often because it gets quite hot. But for this, it's kind of maybe too big. What do you think? Would that work? Maybe not. Might be a few sizes too big. Today I've done some soldering with a hot air station. I can show you that too. Now that we're at this showing of things, right? So this is Orange Pi, Orange Pi 5 Plus. Fantastic little board with HDMI input. So the third slot here is an input for HDMI for cameras. Fantastic. Double Ethernet. Great little board. And I've cooked it, fried it. So the power management circuit I have replaced. Still cooked. Is that a nanner bun?
Nanner bun is back. 16 months.
So yeah, I've thanks. I have replaced this thing here, and oh, there we are. This thing here, and you can see my nail there for scale. I have normal or even small hands. It's not a big one, and I couldn't get it booting, and I still can't. But I then looked in the microscope and saw that I had bumped that little capacitor that is small. That little thing, the little gray thing at the tip of my nail. So I brought out the hot air station to try to put it back on its pads, and I think I succeeded. The board still doesn't boot, but you know. And again, we can use the 22 wire gauge cable for scale. That little thing there, I had bumped, and it was a giant pain because like even my smallest tweezer, I have some. I mean, honestly, I have pretty good tweezers for doing this that I got from Jack in the iFixit kit. But like, you see how small that thing is. Like, what the heck? It's like, if I zoom out, you won't even see it. It's so tiny. Like I'm not a surgeon, so I mean, under a microscope doing this, my hand is going like this, trying to push it in place. Yeah, it was a terrible time. I did not enjoy myself, but I think I got it in place. Honestly, I don't have anything with magnification great enough to see, and I don't even have a test probe on my multimeter large enough to see if I have continuity and if it is properly seated. So I don't know. I kind of think I should, for now, give up on this thing.
Jack Jones is back. 76 months. Will we see iPhone smoke tonight?
I hope not. Yeah. But I'm proud of myself for managing to fix it in the first place. That little thing here. That little thing. There's 4 components in that area. And I managed to move one of them without fucking the others up. And then you might ask, why doesn't it boot? Good question. I've only tried powering it off the USB-C port, which is the normal way of powering it, and that doesn't work. It draws some current and it like stuck in a boot loop. It just blinks a little bit on the red LED. It doesn't do anything. And I ruined it from backfeeding it too much voltage through the GPIO pins up here. Most likely that's what happened. And when it died, the only thing that drew power was the power management IC, and it got super hot. So I replaced it, and it still doesn't boot when powered off USB-C. And that could be because I've fried the USB-C chip up here as well, or something else, or a capacitor, a fuse, a million things. It does take power, but it doesn't boot. It just blinks. So I don't know what's up. And it doesn't draw enough current for long enough for me to check with the USB-C power meter to see if I get any draw. Yeah, I do sort of have access to the schematics, but I can't really figure them out. Yeah, they sort of like they don't link what is on the board with what is on the schematics, right? So some have like labeling on each component, like this is capacitor 14 and this is resistor 212, and this is, so you can like trace your way back on the board compared to the schematics. The schematics they provide is more of a map, and I don't know how the map is connected to this board. And that's sort of what I'm investigating tonight. This is the new guy. This is the Rock 5A, which is the latest Bellabox supported board. This is the, for comparison, this is the Orange Pi 5 Plus. So this is much smaller. It doesn't have HDMI in, but it is absolutely perfect for accepting like an RTMP stream from a GoPro or from an iPhone, which is what we're going to use it for. And this is, compared to a wallet, right? It's tiny. So it's like credit card size. It's like the same size as a Raspberry Pi, 8 by 6 centimeters. And where we left off before I brought out the Orange Pi 5 Plus is, good evening, Noxa. It has a fantastic power management on board. It accepts anything from 4 to 24 volts. It can do PoE with a hat. So it has PoE pins up here for a hat. It doesn't do PoE by default, since PoE is what, 32 to 52 volts. It can't go that high, but with a hat it can do it. Not useful for me because I want to use my batteries directly without voltage regulation externally. I want to use only the internal voltage regulation to save on components. And I also don't want to use the USB port as it is, because the USB port as it is sits on the side poking out, which would add bulk. Even if I use a, didn't I have one right here? One moment, please. Shit, I had it just a second ago. Sure, we'll find it. I'm trying to look for a 90-degree USB-C cable. But I realized I have this one. That will work for the example. So even if I use a 90-degree cable, well, this is not the 90-degree I thought of, but it works. It bulks up the whole device considerably. So what I want to do is I want to, is that a monk?
Monk 9400 is back. 11 months.
Welcome back. Enhance. Enhance. Yes. So I want to solder this wire onto there. Not this wire, but this is just an example. Let's use the other end because that was such a mess. Onto there. To that little pad. because that little pad is the test point for the voltage input. And that I could see in the schematics. Let me show you. Unenhance. Now you guys will look at the monitor. Let's see how that turns out. So here's the schematics. Click. For the device. Let's enhance. Do you like my screen capture, chat? I'll try to zoom in and show you guys what's going on here. Oops. Here we go. DC in. Maybe if I rotate my monitor a bit. Imagine if I could screen capture. That would be fancy. Can you see up here? It says voltage, 12 volt DC in, right? And it comes down and it goes out to the bus and whatever. And here we have test point 1. I believe that is the little point that I showed you guys with the wire. Why do I believe that? Because it's the only test point I can find on the entire board that shows a plus voltage. All of the other test points show nothing. And this test point that I'm measuring on the back that I want to solder to, right? It shows 9 volt if I hook it up to a USB PD device that can do 9 volts. It shows 5 volts if I hook it up to a USB device that can only do 5 volts. It shows 12 volts if I hook it up to a USB PD device that can do 12 volts. So that to me means this is a part of the voltage going in to the voltage regulator, and it's only one of those test points. So I feel quite confident that I can hook it up there. What I can't figure out is this SARADC, which stands for synchronous something array jump something DC. I don't remember what it stands for, but whatever. And this is where I would argue you should shove power in, because it's going through a resistor as well. I don't know actually why that matters, but it probably limits how much you can push into it. And it also has a connection to ground and a smoothing capacitor. So I'm like, wouldn't this be where you put it in? Whatever. But it also shows here a point for 12 volt in. But where's that point? What's that? That I can't figure out. And then here is V bus type C. So voltage bus for type C, you know. So if I scroll down a little bit, here we have a USB-C type 115HO, which is the connector itself, right? Ooh, drop the board on the floor. Oopsie. So this connector right here is called a 115HO. So that's the connector, right? Everyone following along? You got this? You understand? Good. And that is this connector. And we see the display port and the USB data, USB 2.0 data, and the TX and the RX for USB-C, which is just not used. And we have 4 ground and 4 V-bus, 2 on each side, up and down. So it's a USB-C connector. Has 4 ground and 4 power pins. Sort of like 1 here, 1 there, and then ground on the outsides on both up and down side. So it's mirrored, right? That's why the schematic shows 4 of them on each side. Whilst there are actually only 2 ever connected at once. And the reason it's 2 in the first place is sharing, I mean, it's tiny wires, right? So it's sharing the current over more connectors. Whatever. I know from the specifications of this board that you can shove USB-C PD or any voltage between 4 and 24 volts into the USB port. That means if you take a USB-C cable, you cut it off and you solder a power supply to it, and you just feed it 4 volts or 24 volts. 4 to 24, right? If you just feed it that voltage, DC just right into it, it will be fine according to the specifications of the board. I could cut up a USB-C cable and confirm this, but I don't want to do that because tiny wires, and I don't want to use the port. I want to completely remove the port. And if we follow the ground pins, just goes to ground, right? And that connects to all of the ground of the board everywhere. And it's like, whatever, we don't have to worry about that. Ground is fine. There's plenty of spaces where we can solder ground to the board. So it's only the positive connection that we need to worry about. And the 4 B buses, A4, A9, B4, and B9, goes up in this pipe here. Let me go up a bit. And here we have 2 smoothing capacitors, one 10 microfarad, which can do 25 volts, and one 104 something, right? It doesn't really specify, it just specifies 104, 25. And a test point 2. But that is after the smoothing capacitor, so it should be a ground test point. So that should not show voltage. It's on the negative side of the capacitor, so this should be, yeah, this is probably just like a pull down to ground, so it's no leakage voltage, no, like, it probably smoothens the input as well and make sure we have a more stable power. Right, it's probably not for discharge, but it could be used for discharge, whatever. We don't have to go into that because that doesn't matter for me finding out where I'm to hook up my power. Right, so it goes through here and it goes up here, and it has this part of the schematics, which I haven't really figured out. So we have a resistor, 100K, and here we have a resistor that is 8.2K. Don't know what it does, I don't know why, and another smoothing capacitor, 100 nanofarad. Right. Pro tip, the SARA DC VIN4 means VIN4 on the SARA DC chip. So it's not an input. Interesting. But it's voltage in. So that might, this component might show up somewhere else then. Like, oops. So that might just be like a simplification for the sake of drawing it. Yeah, here we have the SARA DC. Let's zoom in on it, see what it does. So it's a 12-bit power management, right? This doesn't make a lot of sense to me. Oh, that is a part of the RK3588S? Oh, the arrows means connections to something. Thank you for educating me, Jack. Here, I mean, it might have multiple of these SARA DC. Let's use the search feature. Right, so here the RK3588 is the CPU, or SoC really, OTP TSA DC. Interesting. And here we have the voltage in key, recovery, HP hook, boot. Interesting. So that doesn't mean I know what they do. But this is showing a 1 nanofarad 50 volt capacitor. Interesting. Let's see if I find it anywhere else in this document. Went back again. Let's try that one more time. Live production at its best. There we go. Here is the mic input that feeds to the analog to digital converter. This is the mic jack, or the combo jack, the mic and headphone jack. But that goes to voltage in pin number 3, not 4. And here we have the DC input side of things. And that's not the last time it shows up. The recovery key has a voltage in as well. So a normally closed, right, that's how they do it. A normally closed, so you can, when you click the recovery key, you open it. That doesn't make a lot of sense, because it doesn't really have a recovery key investigation. I don't think I have seen a recovery key on this thing. Can we turn off the light a little bit? For you guys too. Well, let's switch to the ultra wide so we can go in real close. I have not seen a recovery key on this board that I can think of, because I believe that you do the recovery by shorting pins here. So up here, where I hold my finger, pew pew pew, can use a pointing device for making it easier. Here we have a recovery and a mask rum, and on other boards these are click buttons, but on this one it is not a click button, and we have these unpopulated holes. And I assume when you short these two pins out, that it acts like if you clicked the button. So that is what the recovery key is, in my opinion. But, and then pin 1 and pin 2. But if we look here on the computer, we kind of need to angle it a little bit. Where we have it, it says the here's going to the SARADC chip through a resistor, and here are the 2 pins that I showed on the board, and it says NC, which I would assume was nominally closed, but it might be like not connected. I'm not sure what NC stands for here actually, but doesn't really matter. It does say there's a J8 connector, right? Wait, oh yeah, J8. Oh, did it say J8 on the board? No. Well, the board doesn't have markings for it at least. Oh, J8, jumper 8, interesting. Yeah. That is very likely, yeah. So it's prepared for it, but they haven't implemented it. Interesting. I like that. Thank you for adding that bit of knowledge. Does it have it anywhere else? The mentioning of this thing here? No. No. Okay. And let's go back to the DC part. We went through, and I think we have got some more knowledge to work with here. Let's see if we can find the DC input. Oh, let's look here, by the way. Let's see if we can find this mysterious analog to digital converter anywhere. Come on, Sarah, where are you hiding? I'm not seeing Sarah anywhere. Nope. Okay. Maybe it's just not going into that detail right here. But this is the here we can see the broad overview of what the input side looks like. 12 volt in into the RK806-1, which is one of these. I just happen to have one laying around because that's what I replaced. It's this thumbnail size thing that I replaced on my other board after frying it. This thing here, that is an RK8061 power management IC that I haven't yet managed to fry on this board, and it sits right there, the fairly large 7mm thingy. The test points are labeled on the board view. Ooh. Oh. Oh. Board view. Board view. Board view. Board view. Board view. Is that a different file maybe? Is that the SMD? And that's the component. 2D file? Oh, that doesn't do me any favors. Oh no, I closed it. Board view. Board view. Board view. Not this one. In the schematics file or what? Component. Let's check the SMD. Ah, this might be the board we're looking for. Maybe. Enhance. It is. And this is test point 1. Man, I'm almost a little. So chat, if you haven't figured that out yet, I am in over my head with these things, but here, test point 1, like we thought. And if I meant to sort of try to point it out to you guys, it's that's the one. That's the one right there. Right there. Right there. Interesting. And it's got C10 for capacitor 10. And if we then try to go back and open this one at the same time as the schematics, new tab, and then we open the schematics and we go to DC in, which is sort of at the bottom of the document. DC in. We have it right there. Test point 1. And as a resistor, so where's the capacitor 10? Is it that one? Yeah. That one is the capacitor 10. Right. Then, if I am to translate this in my head to how I understand it for you guys, if I am to feed power here, everything is fine, nothing explodes. And this is just a rail that connects to the test point. There's nothing in between. But a part of this rail is this C10, that is a smoothing capacitor. But if I connect power there, or if I connect power here, should not matter. And is there anyone that understands this part well enough to say yes or no? Thank you for that translation, Kyber Spy. Yeah. Right. Successive approximation register. Totally knew that. Because to me, using the test point 1 for the voltage in just makes so much sense. Hi, Serial. It's been a while. Yeah. Hi, Frankta. We are trying to power this board in a way it was not designed to. It has a fantastic USB-C port for power, in that it can take USB PD from a power bank or wall power brick or whatever you want to put in, or you can just feed it DC with a voltage between 4 and 24 volts, and it has a built-in voltage regulator. This little thing here, that little thing there is the voltage regulator, and the connectors are way too small for me to solder a wire on. Like, I can't solder that. But I have this gold circle with a white outline, which is a test point. And I'm now trying to figure out if it's safe to solder to that test point. And we're looking at the, if you can focus, I don't know. We're looking at the board view here. Oh no, sorry, the schematics. And this is test point 1, which is the one we want to solder to. And it's in line with the input. So here's the, if I plug it in a USB-C cable, that's where the voltage would come, up this line, all the way up here, and then this is to the board and all the other fun stuff. But here's the test point. So I'm betting the $150 the board costs that I can solder to this. Why I don't want to use the DC in? Okay. So I'm in the pursuit of tininess, because this encoder is to be pocketable, right? So this is a case for the old board, and the old board went in like this, like that, to protect it. And this even disappears in there, so all of the connectors are hidden. And this extra bit here is for an HDMI cable. So when the HDMI cable is plugged in, it also is protected. And you can see the clearance up here is very slim. Very slim. I want to make a similar case, but for the new board. And the problem then is that the USB-C connector for power sits at the top like that. So that would make the case almost like, not twice, but a lot bigger than it needs to be. So what could I do? I could desolder the entire USB-C cable and then just solder the 4 V-bus terminal point wires thingies from the USB-C, right? So I could basically forgo the USB-C connector, the 115HO USB-C connector on this board, right? But I'm thinking it would be just so much simpler to solder to the test point and keep the USB-C connector. Because, you know, maybe in the future we would want to use this for something else. And then it's convenient to have the USB-C connector. Long term though, I actually would like to remove everything unnecessary from this board, meaning remove the headphone jack, remove the HDMI outputs.
Frankta is a Prime sub.
Thank you, Frankta. Yeah. So removing all of these, because this one sticks out probably 3 millimeters. And you might not think 3 millimeters matters, and it kind of doesn't, because I guess I could move the Wi-Fi dongle to the middle port, and then it's fine. Yeah, then I can make a case that is just the size of the board and not use the analog audio. Okay, let's read some chat. Jack is saying, and Toby, hi, nice to see you found my channel. Toby is a fellow streamer and tinkerer, but he's from Norway and I'm from Sweden, so we can be friends. In the bottom right, there is a CH224D, which is the USB-C power controller. And that's that. I think we have confirmed that it's that one. That is the CH224D. And I have, I think I have the schematics. Yeah, there we go. The schematics for it. And I kind of think it's weird because I'm not counting the correct amount of ports.
Tubby Travel joined.
Nice. I'm not counting the correct amount of wires, but I'm still quite confident that that is the thing. And oh, we can probably see it on the schematic, on the board view. Right there. Let's zoom in. U4. We can assume it's the U4, right? It didn't show. That would have been neat, but it doesn't. So. Oh no, Kyber Spy. The board did not go in like that during operation. If it would have been deployed, which it never were, it would have been. I would have put like thermal pads on it, but yeah, I never got that far. We didn't do it. But Jack is confirming what I believe. He says, and the USB-C V-bus pins are connected to the VCC 12-in, which is how we understand it, which goes to the MP8759 power regulator. Where is that? Is that? It might be the 806-1, but that it's listed as MP8759. MP. Is that on the board view? Can you use search here? MP. No hits. Okay. Let's go over to the schematics. Yeah, so this is the MP8759, which I don't think is an MP. I think this is the 806-1. And yes, if I were to feed it over the test pin up there, I mean, and I would plug a USB-C device in, it would kill the USB-C device. So don't use them at the same time, for sure. Oh, right, you got an ad. Poor timing there, Frank. I'm sorry. Yes, the reason I don't want to use USB-C is that I want to make it more compact, indeed. At some point, you might even be able to hide it in a hat. That is the plan. That is the plan. I have this headpiece, as I call it. So I have this. No, it's not a joke. That's what I'm planning to do. So I have this, and here's the chin mount for a GoPro. So imagine a GoPro sits here, and it's a POV helmet, as I call it. And I ran this with the Jetson Nano, but the Jetson Nano, if you give me one moment, just have to find it. There we go. And then I mounted the Jetson Nano up here, right? The problem was that together with two modems and the Jetson Nano and the capture card and the battery, it got kind of crowded on the helmet, and it ended up just being hard to package it in a way that I felt safe to run. So I kind of discarded it, mostly because the capture card, honestly. So this is the Elgato Camlink 4K without its case, and the length of it is just obscene because I mean the USB port and the HDMI cable and everything, it's just too long to package it in a neat way. So I put it all there. It looked like absolutely stupid. I think I have pictures I can show you. I'm pretty sure I have pictures I can show you. I think I could find it without too much trouble. Pics and clips. Because I think I shared it in the Bella Box Discord quite recently. Because someone was like, oh, why don't you build a setup on a helmet? I'm like, I've done that. Or maybe it's not as recent as I thought it was. Oh, here it is. Here it is, completely built. Open in browser. And it turned out to be like just a giant mess. It's like it wasn't neat. Can we zoom out? But this is with two routers and the Jetson. The reason I put the routers up there is that I honestly thought Wi-Fi used a fuck ton more power than it does. I have since done measurements, and Wi-Fi uses like 0.24 watts, and I can afford 0.24 watts power budget in order to have the modems in my pocket. So I'm now not putting the modems there. Sure, Wi-Fi adds instabilities and potential issues, but I think it's worth it for the lighter helmet. So the helmet doesn't weigh a lot as it is anyway. It's not a problem on the neck or anything. A motorcycle helmet. So this is actually Siri using the thing, and this is without the computer on it. This is with a belt setup instead. And the headpiece like this weighs 1.3 kilos about, but that's just the camera and the headpiece itself. And a motorcycle helmet weighs between 3 and 5 kilos. So like it's not a big weight on the head. It's quite comfortable. I used it for 12 plus hours and it's totally fine. But where this setup sucks, if you pause it here, is you have a wire going across your back which you can get caught in, or when you take it off, say you want to go to the bathroom, sure you can change scene in OBS and not show your stuff, but a much more convenient way, in my opinion, is to just have the helmet be self-contained and take off the helmet, put it somewhere. Or if you want to give it to someone else, you can just take off the helmet, put it on someone else's head, and they keep streaming. So having it put on the helmet is like that. And that is why I got the Orange Pi 5 Plus, which I have here, because this one has a capture card. So instead of using the Jetson Nano, right, and the capture card, it's built in, much smaller, lower profile, which is kind of big, and it uses half of the power. It's so power efficient, which is great. But this is still hard to fit on the helmet because, again, like the sizing of it makes it sort of bulky, but it works. It works. And I had it mounted and I was ready to stream with it, plug it in to power it the first time, and yeah, it let the smoke out. Could order a new one, but I was in the process of convincing Rational, who makes the Bella Box software that we run, to implement this absolute sweetheart of a board, because DJI had just released its Osmo Action 4, which is the first action camera that supports stabilized footage over USB-C as a webcam. And that's like game changing, because then you don't need to run a HDMI cable. It's a single cable setup and it powers the camera and you can use all the stabilization mode, and oh, it's so great. And then I was like, well, fuck this big board, and let's put this board here. Run 2 Wi-Fi connections, or 3 if you want to. One of them is going to be a M.2 Wi-Fi chip, one of these, and the other one, let's remove the big clunky one here. So one is going to be a dongle, and one is going to be one of these M.2 boop, Wi-Fi chips. So like this, and then the power that I'm to solder to it, and then one USB connection to the camera, like that. That's the entire setup, and then you have 2 phones in your pocket for modems, and that's it. For batteries, I plan on using this. This is an NPF 550 battery with 3500 milliamp hour cells, so it's 50.4 watt hours. And this thing with camera consume about 8.5 watts max, but probably will hover somewhere around 6 watts. So this battery and this setup, you know, is 8, maybe more, 8, maybe 10 hours of runtime. And you can see how easy it is to fit this on the helmet itself, like super easy. Like, this is nothing. And the total package would be, yeah, like a 1.5 kilos maybe. So super light and super wireless and super awesome. So that's my goal. Right. That's what we're doing. That's what we're here for. And then you can put like some waterproofing around it, so it's safe to run. Yeah. Is that a TSB encoder on the table? Try going wireless. How much is that? So the easy way, the easy way would be to put the encoder in the pocket, right? And then use a wireless camera. But in my opinion, wireless cameras are not plug and play. Like the DJI Osmo Action 3 and 4 and 2 can do wireless RTMP to the box, and then the box would stream to the computer, and the computer would stream to Twitch. That adds an extra step of encoding that lowers the sharpness and overall image quality past what I think is acceptable. And also, I would still need the battery on the rig to power the camera for extended periods of time, and I need to open the app to start and stop the stream, and need to have that synced and connected. And this thing weighs 50 grams, and if I add it to, I remove one encoding step. I slightly increase the power consumption on the helmet itself, but in a point like I'm maybe removing an hour, going from 9 hours down to 8, which is an acceptable amount of battery life, because I have 2 of these. So if I put in a power a plate, right? One of these. If I put in a plate like this, after 8 hours when the power runs out, you would just boop, and then boop. That's it. So it's not. In my opinion, power draw is not a complicated matter for this setup. It's already solved, in my opinion. So yeah, for stability, for ease of use, I think going the USB to this from the action cam is the way to go. The perk of going wireless would be that you could take the camera just off this, quick detach it, and you can handhold it filming yourself or giving it to someone else. So wireless is kind of neat, but I don't want to add that extra step of encoding and lowering the quality. The last couple of days I've been running the iPhone 15 that we're streaming from right now into a Bella Box setup and streaming to Twitch that way through an OBS server at home, and the quality is just mind-blowing. Like I'm in love with that setup for Siri, not for me, but for Siri, for most things. If you have a camera operator or if you're filming yourself selfie style, it is so nice. It's fun to use. It's convenient. Where am I going? To Twitch. It's convenient. It's fun. You can do like powerful zoom ins to like 15x digital zoom or something. Like it's wild. Let's do top 7 days and not featured. Oh, like this. This is the iPhone 15 Pro going into a Bella box, going to OBS at home, and then streaming to Twitch. And the quality is just, oh, so good. The amount of dynamic range the iPhone can produce beats the dynamic range of our Sony A7S III, 100%. It's just bonkers, the dynamic range, in a good way, in my opinion. I love it. For IRL content where you can't control the lighting, having that wild amount of dynamic range is so worth it. So I just think it's a better camera. And do I have the sunset picture? Here we go. And like this is filming the sunset, and the dynamic range is just wild. And the zoom, so she will zoom in a few seconds. Like maybe could have fast forward. I don't want to miss it. Maybe could do this so you guys actually see something. The zoom you can do is wild. It's got good enough stability control, and it's so easy to just pinch to zoom to get in there, and it's fast compared to using like maybe if you have some broadcast style lenses you could zoom this fast, but yeah, the range going from 14 millimeters I think to something like 200 millimeters. There's no DSLR mirrorless lens that can do that on the market. And also has a front-facing camera, which is cool. So I just love it for streaming. It's so much fun. I have not had the opportunity to try, say, a Samsung Galaxy S23 Ultra or something like that. So I've not compared it to the best offerings from the Android side of things, and I bet it's an equal fun experience. And for sure that the iPhone lacks the zoom of the S23 Ultra. Now we can say has got nothing on it, but I've had such a fun time, so I have been considering completely scrapping the idea of using a GoPro in the first place and just putting a phone mount on my helmet and then calling it a day. That thought has been had, but the iPhone is so expensive compared to it's $1,500 versus $500, so it's like quite more expensive and kind of fragile. So, and huge, yes, it's bulky, but it only weighs 184 grams, and a DJI Osmo Action 4 weighs 146 grams, out of which I think 46 grams is the battery. So if you run it without a battery, you would lose down to 100 and, is it 110? Yeah, the battery weighs 36 grams, so it's 110 grams without battery. But then you would add 50 grams in this thing, and then the battery weighs 190 grams. This one weighs 190 grams, so it would be a heavier setup. But then again, you would need to charge the iPhone, so the battery you would need anyway, right? Because the battery on the iPhone is not replaceable, or at least not quickly. The iPhone 15 Pro runs about 2 hours of streaming whilst being used as a modem with a bonded connection over Wi-Fi and the internal. It runs for about 2 hours on the battery, which is pretty neat. And it's got a 12.4 watt hour battery, which means that the power consumption streaming is 6 watts, which is very good considering it's a modem and encoder and display and camera. It's like nothing beats it in the streaming world. This thing, just encoding and a Wi-Fi connection, uses 2 watts, and then the camera uses another 3.8 or so watts, but that's without a display and without a modem, and a modem can use something like 2 to 4 or 5 watts, so it's very efficient. Very efficient for sure. Like the Live View Solo uses something like 16 watts, I think. Yeah. You can power the board using the GPIO 2 and 4. No, you can, Jack. You can, absolutely, 100%. But only with 5 volts. So you can see here, woohoo, let's zoom in. It's even marked red on this one. And then you have the black there. So yeah, the pin 2 and 4 are positive, and then 6 is ground, or 9, I think that is. This is how I power the Jetson Nano. Ta-da! So that's how I have powered the Jetson Nano since we got it a year ago or something. And that's what I did on this one too. And it let the smoke out. I just assumed it would work, and it didn't. Oopsie. We learned something though. We learned something. But on the Rock 5A, which is this board, it specifies in the manual that it can take 5 volt DC over the GPIO. It can take USB-C, PD. It can take power over Ethernet, 32 to 52 volts if you have a PoE hat. And
Data got joined.
was it Daddy got? I'll check who it was. Hi. And it can do 4 to 24 volt over the USB-C, which is how I want to power it, because then I can power it directly from the battery without further voltage regulation, saving on components on the board. The voltage regulator I run, for example, for the Jetson Nano, to be able to use the V-mount batteries, look like this. It doesn't look like this normally, but I have removed its case and put some heat shrink around it. So this blob of a thing I can remove. This takes 10 to 24 volts and makes 5 volts out of them. And if you look at the board, you can understand why I don't want to have that blob on it, because it's huge compared to the board. It would add a lot of space taken up by it, so I don't want to do that. But I want to be able to power this board with a V-mount battery, which is this big thing. This is 100 watt hours. Or I want to power it with this one, which is an MPF battery at 50 watt hours. But like you can see the size of the MPF, this is half the power of this one. But you see the size is, you know, just that much neater. If we actually take 2 of them and put them next to each other, you'll see how much power space we'll save. And it's lighter. 2 of these are 190 grams each. So 2 of them is 380 grams, and this is 480 grams. So I'm saving about 100 grams. And that power saving comes a little bit from this case being thicker. These batteries are slightly less power dense, but they can output more power. This thing can do 130 watts, I think, whilst these can only do like 18 or something. But together it would be, you know, just under 40 watts, but this can do 130. So the cells are much stronger. Well, they can produce more current. It also has a different locking mechanism that weighs more, and it has like USB on board and charging boards and yada yada yada. But other than that, they're fairly similar. They're both 18650 cells inside. But these are just smaller, lighter, cooler. So I plan on using them. But it's nice to have the flexibility of being able to use the higher voltage as well. And that's what this thing does. This is the, on the board it says MP8759. But in my opinion, this is a, what was it called? It's a CH224D. Right. Which is, no wait, no, never mind. Sorry, strike that. It is not CH224D. That is a CH224D. So that's the voltage regulator. Going in there. So I want to use that little tiny thing instead of this giant thing. They do about the same thing, which is pretty wild. Powering it via the regulator is just smart. If you power it without proper protection, you risk explosion. This is true. But if you're powering it with a regulator that can fail open, which I don't know actually if a synchronous power supply always fails closed or open. I don't know. But if it fails closed, you can send pack voltage to the device anyway. So, shouldn't matter, right? So Jack says, so the way I understand the DC input section on this is this. The V-bus pins from the USB-C goes to the MP8759, which can accept anything from 4.5 to 26 volts, and the CH224D just asks compatible PD chargers for some voltage or just accepts 5 volt input. Right. The MP8759 then powers up the VCC system in bus, which powers the board. This is, maybe you are right that the CH224D is just a USB-C, what is it called? E-chip? The same as is in a USB-C cable. It might be just an E-chip, now that we talk about it. Then, I wonder then if it's the RA620i, that big thing, that is the voltage regulator. You think? Because this is the power management IC. Oh, hi Tom. How are you doing, buddy? Ooh, before it was data gut. That followed. Right, where were we? Board view. Right, let's zoom out. And this is the bottom side. U7. I wonder. It's labeled U1. Interesting. How did you figure that out? U4, U7. Let's use the search feature. Find U1. It says on the schematics. Sweet. All right, it sits over there. It sits on the left side of the board. Wait, no, is that the top? That's the top. Huh. Yeah, Tom, this is the latest stuff. Like, this thing is fun. This is a fun little streaming device that you can hide in a pocket, which is why I'm getting it, because put this in your pocket and you got a bonded stream to the internet. Flipping amazing. Okay, let's see if we can find the U1. Oh, it's right next to the giant inductor. Maybe this little thing. Let's zoom in. Enhance, enhance, enhance. You see that black thing next to those two giant capacitors? On it says, is that A99P45? Something like that. But that little thing there, next to the giant inductor. U7 seems to be related to the DisplayPort HDMI stuff. That's very possible, actually. That would make more sense. Because why would Alexa make a voltage regulator? It just didn't make a lot of sense to me why they would use a voltage regulator they designed themselves. Right, and then it's got huge leads going, huge traces going off that little black chip. So yeah, okay, cool. I mean, there's no traces that I can see here that I would feel safe with soldering to, so I still think the test point there is the best solution. So that's the test point. And then we solder a wire to it, right? Like this. So that little gold thing, just put the wire like that, and we're good to go. I wonder where we're going to solder the ground. That I would imagine being ground, actually, because it's in the screw hole, so we would ground it to the case. Oh yeah, I was just memeing with the 14 gauge. This is 22, which is a little bit more suitable. Actually, the same diameter. So that's probably what we're going to end up doing. And since we're running like only 3, maybe 6 watts through it, we could have even thinner, but I don't have thinner cables. That's the thinnest I have. So that's what we're going to do. And like we discussed before, my inferior soldering iron, I have found a small one. It actually is the same size. I think this is like a 1/2 mil tip. And I could see myself do this with a lot of balls, which I don't really have right now. But yeah, I imagine this being possible to solder. A little nerve-wracking, but I think I could. Funny that I have Lars here. I was lurking in, well, I was chatting actually in Lars' stream before, and he recommended this thing, the TS101. And the TS101 comes with a 0.5 millimeter tip, but they also sell a 0.2 millimeter tip to it. And that's probably much more fun to solder this with. The grade? Shit. Yeah, so Toby have one, Larsen have one. Yeah, this is probably what I would want. Because like you could argue that I should have like a Weller soldering station, right? I get that. You could argue it. But I like the idea of it heating up super fast, which I actually don't know if it does. I just assume it does. And I'll admit that I don't know why I want this instead of a Weller. 9 seconds, yes. It reaches 400 Celsius in 9 seconds. So it's super fast. The Weller might be, but yeah, super fast. Oh, Toby repairs FPV drones in the field. Well, then it's convenient to run it off battery. I just think I will enjoy this one. I have to discuss it with the missus. I think Siri is annoyed by the spendings lately. There's been a lot of investments in streaming gears in the past. A little bit. But I think I could solder this without it. I think. And worst case, it's a broken board. You know? Might be cheaper on AliExpress. It might. I mean, this is from a Swedish site that has it in store that I can have it in a couple of days. I recently got a hot air station. And yeah, failed my first repair. I haven't given up on it yet, but I didn't succeed in the first get-go, which is unfortunate, but you know, we learn. Oh, I'm checking some. I have some good news, chat. We have now been streaming for an hour 15 minutes, whilst charging the phone up to 80% from about 50. This is streamed. That is true, Jack. I might have succeeded with my repairs, but there could be more things broken on the board. This is true. Streaming with an iPhone 15 Pro, connected with a USB-C hub that can do PD input. So I'm using the PD input to charge the phone. I'm also connected the Rode lav microphone thingy. Let's see. Try and show you. With this thing on that USB hub, and the audio works from it. It's cool. Charged it too. Picture choppy. I did swipe down, bringing up the interface. It might have done something. It's fine there. Good, good, good. And the phone hasn't overheated yet in an hour, doing 1080p 60 fps at 8 megabit per second directly to Twitch. We ran into some overheating issues when we were out IRL streaming the other day. It actually thermally not shut off, but it started lagging. So we lowered it to 30 FPS. That was using a different app, a much older app that hasn't been updated in a while. So I'm thinking, wait, was that software encoding or something? Don't know. It just shut off, but this has not yet shut off. So I'm very optimistic. And the ambient temperature in this room is 23 degrees. So that's very nice. Jack can get the iPhone 14 Pro to overheat when wireless charging almost always. Right. We have the past 2 days, now wait, last night and today, tried it streaming with the wireless charger. We got one of Apple's MagSafe chargers, and it has not overheated the phone, Jack, whilst charging and streaming. But we've only used it for an hour and a half. But I imagine that would be enough to send it to thermal limits. MKBHD, I presume you mean? Yeah. Well, I'm glad to report it has not yet overheated using this app at least. Stop charging for a while, then it cools down. Interesting, interesting. Well, yeah, like now we're charging over USB-C, so that seems to work. We have gotten up to 80% charge, and I think I started at 40. So that's good. And this USB hub is just so wild that it works. I plugged in my Ethernet cable, and it just pops up in the dynamic island on the iPhone, right? Like a little Ethernet symbol. And it just works. I'm connecting an iPhone over Ethernet. It just works. Like, what the fuck? And then I started, we're using Speedify right now, actually, to bond the internal. I'm streaming over 4G right now. So I'm bonding the internal 4G modem and the modem, well, actually 5G internal, whatever, but I only have a 4G connection, and the connection inside of this phone that is shared over Wi-Fi to the iPhone, and those two are bonded. But I could also connect this 4G router over Ethernet and get a third connection, and I tried it and it works. So Speedify actually sees all three connections and can bond them. Flippin' wild. And I've heard that IRL Pro also can do this on Android, that it can use Wi-Fi internal plus Ethernet dongle. But hey, now we can do it on iPhone. It's not as good as the bonding you get when the encoder is aware of the connections, like using a Bella box or using IRL Pro, because then the encoder can see the quality of each link and predict the encoded bitrate based on it. When using Speedify, the encoder doesn't know the individual connections. It can detect drops. So whenever it drops frames, it will lower the quality. That's how the encoding works when using Speedify. It's adequate if you have really good connection. Then you still get the failing over between the modems, and it can sort of aggregate and get a better connection. But I would argue that Bellabox and anything using SRTLA load link aggregation, right? Anything using link aggregation is much better when you have multiple modems with really poor connection. So if you're on 3 or 4 modems that each have like 1 megabit each, you can maybe get like a 3 megabit stream. But with Speedify, you probably would only get 1 megabit, but you will get something. So it's more about reliability than bitrate. But it saves you when you're like going rural areas between antennas and hopping towers, and you have one good modem and one bad modem. In those situations, Speedify actually works quite well. Not as good as Bellabox, not as good as IRL Pro. But we don't have those options for iPhone. If we want to stream directly to Twitch from iPhone, it's Speedify or nothing. And it's cool because it works. And now we can use 3 connections, which has been the biggest downside. It can only use 2 prior. But now with USB-C, you can use a USB-C hub and Ethernet as well. And it works. Great. I tried tethering another Android phone over USB. The Android phone detects that it can tether and initiates the tethering, but the Speedify software does not pick it up. So I don't know if that's a Speedify thing, that it's not expecting or looking for USB modems, or if it's the iPhone not piping it through. I don't know that. But theoretically, you could also hook up a couple of Android or USB modems and bond that too, which is pretty wild. All the talk, shall we make some action? I have not. Apple software doesn't support Android tethering out of spite. Is that? Do you think that is the truth? Do you think a USB modem would work, but not? Oh, interesting. I have another iPhone, but it's sort of broken and I don't think I can try it. But it would have been interesting to see if I can tether an iPhone to an iPhone. Should we try to solder this tonight, chat? I would kind of need your support emotionally to dare it, because are we on the we're on the macro lens, right? Oops. Let's zoom in here. So that's my target. That little golden circle is my target. And if it wasn't for that capacitor that sits next to it, there's not like a lot of other things I can fuck up in the vicinity. But that pesky capacitor kind of screws me over. As if I touch that and flip it out and cock it up, it's gonna suck. It's gonna absolutely suck. I don't want it to suck, because then I would need to take a tweezer and put it back. And capacitors are directional, meaning they have a plus and they have a minus. And I don't have a microscope where I could even see this component. Jack says it's just a filtering cap for test point 2. That doesn't give me confidence that if I remove it, it will all work anyway. But kinda. That's how I read it, actually. Yeah. Maybe I could. Maybe the board works if I remove it. Maybe. Should we do some probing? That capacitor is not directional. Why not? It's only some capacitors that are directional. Only electrolytics. Really? So an electrolytic capacitor. Oh, do I have one around that I can show you? No. Tiny bit of Kapton tape. You assume I have that? I actually don't have that. What were we looking for? Oh, multimeter. Bringing out my trusted fluke. Just kidding. That's what a professional would have said. It works. It's from Biltema. Right. We were investigating whether or not the corner test points are ground points. Does not seem so. Then that is what? What is that? Are they connected to each other? Let's see here. No? What are they connected to then? Nothing? Is this meter even working? That is definitely grounded, okay. That might be test point 2 then. But I can solder here. And I can solder here, that's ground. So that test point is ground. I say that, but you can't see anything. Let's see if we can enhance and at least give you a vague idea of what I'm probing here. So that test point is ground. But I could probably more easily solder it to the USB-C port support. Like the 4 pins that the USB-C port sits on the board with, right here. Would probably be an easier target, like nothing to fuck up around it. I guess this test point is a bit of an island, so unless I flow solder over to the middle port, which is something else. Oh, and I could of course use the up here. Can use the ground on the GPIO pins too. I fundamentally have nothing against running. Let's see if I can get 2 ends here. Let's just grab a thick wire for demonstration purposes. So I don't have a problem with running the plus voltage here and the negative voltage there. That doesn't matter to me. So I could do that. Or I solder the test point. What is easiest? This for sure, because it's a huge pin. But in the future, my plan is to remove all of these because they protrude outside of the USB, what's that, the Wi-Fi chip, which I put somewhere here. So I want to make this as slim as it possibly can, which means that I will end up using this Wi-Fi chip. So that will be the determining height factor. So whatever that is will be the height of the board and the case itself. So that is just under 1 centimeter. We gotta have some clearance on the back as well, so around 1 centimeter. That's pretty flat. That's kind of awesome actually. But the pins stick out more than that. So I remove them, cut them, something. Test point 6 is actually ground. Oh. Let's see if that is the test point 6 then. Thank you, Jack, for helping out with this. Down to the lower side. Test point 6, yes, that was the one I measured. Test point 6. So if I solder the test point 6 and test point 1, the cabling will be kind of neatly together. Look awesome. And I imagine soldering to the test points being not easy, but doable. Wait, what's the thinnest solder I have? 1 millimeter. Okay, now we run into the new issue. Shit, I am unprepared for this chat. Let me remove the Wi-Fi chip here. So, enhance. The voice command doesn't work today. Enhance. Enhance. So here we have the test point, and here we have my soldering wire. It's probably not what you should be using if you want to make your life easy, because it's probably a little thick, don't you think? This is the hard drive for the computer, the eMMC module, a 16 gig. Woo! Maybe sacrifice the ultimate goal of a few millimeters to save hours of desoldering the connect. Okay. Maybe sacrifice the ultimate goal of a few millimeters to save hours of desoldering connectors and many chances to break the board. That is a hot take. If I am to entertain that idea, it is not a terrible one. I even have, if I can find it, I had it earlier today. So where has it snuck off to? I even have the perfect USB cable for it, is what I'm gonna say. A fairly slim. No way! I just realized the thing. Hold on, chat. I have a box of cables. Is that a pie? Also, hi. Hi. Hi, Drake. In here is a really slim USB-C 90-degree cable, if I'm lucky.
Edu Kada'a joined.
Edu, what are you building? The smallest IRL streaming setup possible. So I have a bunch of random non-terminated USB-C cables. But I am pretty sure and very optimistic that I have one that is a right angle. That is a very small right. Ow! Something poked me. Haha! We found an electrolytic capacitor. These are directional. Whatever. I bet one person in chat cared. Other than that, yikes. Yikes. Why are all these straight? That thing is stuck in my head, Jack. Thank you for making it. So those who are not in the know, my girlfriend, who is a streamer here on Twitch named Siri, she has a lovely voice. Oh, found it. She has a lovely voice alert with her and me singing very awfully the melody of Jurassic Park intro thingy, theme song it's called. It's funny as fuck, in my opinion. So yes, I stated that I have the perfect USB-C cable for this. And that might be true. Boop. Very slim. 90 degree. No other end. So I could just feed the voltage in here. And why I don't want to do that, like, okay, why I want to do that Just splice the wire and connect it to the battery and the board is powered. No soldering required. The downsides, it would build 16 millimeters on the case. And it's not just, I mean, 16 millimeters might not sound a lot, but it's 16 millimeters of the whole thing. And this is meant to go into a pocket. Does this width matter? Is it going to be fine? Easy. Probably. I think the thickness in combination with width is a problem, but the thickness is still less than the M.2 module. So I can keep the case thin all the way back to the USB-C ports, USB ports, right? And what I want to do is to remove the USB ports and the network port, because then the whole thing could be 1 centimeter instead of, I think, 2.4 or something like that, right? So this is, yeah, like 2.4 would be a safe thickness of the case. And it's going to be very comfortable anyway, because this part can be flat and then this can be the thick part. So if you imagine a pocket you put it in, right? It's going to be like tapered, sorry. It's going to be like slimmed down like that. So it's going to sit comfortably in the pocket. And 2.4 centimeters, even if it was 2.4 over the whole board, it would be a comfortable fit. It's just, it would be even more comfortable if it didn't have the hump of the USB port. And then it's like, well, how are you going to connect peripherals? Or like, how are you going to work without USB ports and without Ethernet? Here are the 8 pins of the Ethernet, right? 1, 2, 3, 4, 5, 6, 7, 8. Can I not just solder an Ethernet cable to this and call it a day? I argue I can. I haven't tried. And here we have, is it 8 times 2? So 16 pins for the USB 3, the 2 USB 3 ports. And here we have 8 pins for the USB 2 ports, 4 per pin. And that means that, I mean, this is a bit hard to solder, but because I can't see the pins, but technically I could remove the shield and solder wires between the 4 pins here and the 4 pins there, and then just put it like that or whatever, and it works, theoretically. Saving weight, saving space, and if it works, increasing reliability, as this cable can be pulled accidentally. And if you want to play like streaming grenade and throw this between each other, having soldered connections just feels better. It feels safer. So quite excited about this. Just hot glue? Oh, maybe I should hot glue it. How's Easy doing tonight? I saw you were playing Grounded earlier. Oh, yeah, Jack, if I pre-solder the wires, there would probably be enough, with some flux, right? It'd probably be enough sticktivity to just put the wire against the point. Because, I mean, it's a gold-plated test point. Shouldn't they be fairly easy to solder to? Like, if I clean it with alcohol, put some flux on it, I mean, I should be able to get away without tinning it first. Should be, could be, might be safe. Right. That's interesting. Chat, do you think it will work? And of course, Lewis Rossman level of flux, of course. What else? Anything else would be a crime against humanity. Oh, I have actually not checked the stream quality.
It's 1 o'clock.
Is it 1 o'clock? That looks pretty neat. So this is direct to Twitch. No OBS server in between or nothing from the iPhone 15 Pro. The digital zoom is noticeable. I think it looks better on the screen than it does on the stream. But I mean, if it's just about showing it off, it's perfectly adequate. Like, I'm going in circles here. Pay attention, not to that. This is the soldering joint I am to make that. The wire to the test point next to it. Can I do it? Probably. And I think honestly looking at the camera preview is my best chance of success. Because it's quite a lot of zoom. Makes this thing look big. But you see my thumb here next to it. It's not a big thing. Sorry if you guys got too much of a close-up on my thumb. This is the latest card, yeah. And if you want to see the sort of the generations of Bellabox setups, right? So this is the OG, the Jetson Nano. It's a 4 GB card. And the Jetson Nano is kind of cool in that it has the heatsink up here. The little board that sits on top is the actual computer. The rest of it is just a carrier board for the I/O. And it's huge. It's huge and clunky. But this is kind of ancient. I don't know, how old is the Jetson Nano? Like 8 years, 4 years? I don't know, it's an old piece of tech. So it's not very power efficient, which is the biggest reason I get rid of it. There are much smaller carrier cards. There's actually carrier boards that are this size, 8 by 6 centimeters, which is a Jetson Nano, Raspberry Pi size, right? So there are carrier boards you can get that would make this sort of this size, but it uses too much power. So the Jetson Nano is out. And then we have this one, which is the absolute best setup for IRL streaming right now, bar none. It's incredibly power efficient, uses about 1.8 watts of power to stream 1080p 60 at 12 megabit per second in H.265. That's wild. Absolutely wild. It has 2 Ethernet connector, so if you want to use Ethernet modems, you can do that and bond the connections. You can plug your HDMI camera in here because it's a capture card on board. It's fantastic, absolutely fantastic. You can use an M.2 Wi-Fi chip right there, and that connector. So this is like the gold standard. It's like $108 if you order it from America. Fantastic. And this is the brand new, actually. It's only a week old that this was supported by Bellabox. And it's smaller, but it doesn't have onboard HDMI capture. So if you're going to run an HDMI camera, this is the board to get. But if you're not, then this is the board to get because it's smaller. And it has better powering options, in my opinion, since you can power it with 4 to 24 volts through the USB-C cable. It also does USB-C PD, which the other one doesn't. And I imagine this being the board you choose when you're using a phone or a GoPro or a DJI Osmo Action 2, 3, or 4, or if you're using a GoPro, for example, over RTMP, because this can take RTMP and then stream it to your OBS server. This is the one. You think you prefer to use it with a CAN link? Are you insane? Are you insane? How can you prefer the CAN link? How? In the what? This is the most fun comment I've gotten today. Fun as in I'm interested in what your reasoning is, how you want to use this. Okay. Jetson Nano Cam Link. This combo uses like 6 watts of power. And look at the size. This is like what, 16 centimeters long or something? And you have to plug it in like what the like, why would you want to use that? This capture card that is built into this SoC can do 4K 60. And the board can stream 4K 60. Why would you want to use the external capture card that is like super sensitive for disconnections and uses like 1.2 watts of power and adds bulk, rather than to use this super tiny, super awesome board? I'm just, what? Because you can choose where you want the cable. Or like, you can't choose where the USB cable is. So you would have to plug the USB cable in, and sure, then you could route this around. But why is that better? Like, I'm trying to understand you. I'm not saying you're dumb. Why is this better than that? And just routing that cable wherever you want it to go. Or if you don't want it with that shape, like if you for whatever reason want it to point downwards, you can do that, right? And then you like that, and then it's like even slimmer. I mean, a USB cable is like, what's the difference? A few millimeters? Like, I'm just trying to understand it. Or if you use whatever, somewhere on my desk I have a 90-degree cable instead of using an adapter. Like, I'm just trying to understand. I don't get it. I don't have to get it. You're allowed to do what you want. If I only support SDI, I know that would be really cool. And yes, I think you could use the UVC of the Sony A7S-C on this thing. Probably. It doesn't support every type of UVC. You know, it doesn't support every type of UVC. UVC is like sort of finicky. You can get most of it to work, but not everything. For example, my wireless system does not work on this board because it doesn't report the frame rates the way it wants to. Powered via USB? Yeah, 100%. Both of them. So this is the Orange Pi 5 Plus, powered over USB-C, no worries. It doesn't do PD, but you know, whatever. USB-C defaults to 5 volts anyway. This, the Rock 5A, actually supports PD, so it will trigger 12 volts. That's its preferred voltage. So you only draw like 0.1 amp, or I mean actually even less, but yeah, whatever. No, you draw like 0.1 amp when powering this board, unless you plug in like extra peripherals. So this board is absolutely fantastic, and the way I'm planning on using it when I purchase this was together with an Osmo Action 4 over USB. Then you can remove the battery from the Osmo Action 4 and plug it in over USB to power and get a video feed over USB, which is flipping insane. And then you can take, and this is not, I don't have a Osmo Action 4, and you can take it and you can stick it on top of the board like this, right? And then you can take an 18650 cell, which I don't have, or a 21700 cell, and you can put it there, like that, or put it there, or put it wherever, put it somewhere. This little thing, this little hand grenade shaped thing, let's ignore the battery for now. This could stream together with like 2 phones for Wi-Fi hotspots, and it's pocketable, no cables. Like, it would all be like, you could put in a 3D printed case like that, and that would be just broadcasting to Twitch. You would get like a preview so you could see yourself, or you can see yourself on the back screen on the Osmo Action 4. Who doesn't want that? No backpack, just this little thing, just this thing, in a 3D printed case, and you're done. Flipping amazing. Or the Osmo Action, or the GoPro for that matter, can stream via RTMP and you wouldn't stream to Twitch with that because it's super unreliable and you can't bond the internet connection, but you can stream to this thing, right? So this wireless into that, and that one streams to your OBS server, right? So this is wireless, this you put in your pocket. You can put it in your pocket. It's smaller than a phone. Look, it's smaller than a phone. You just put it in your pocket and you have 2 iPhones or whatever phone you want as modems to it. And this is how you stream, by just holding a GoPro. Just flipping wild. I love this tech. Not everyone is about to desolder connectors to make the card 2mm thinner. No, but I might. I want to build the most amazing, fantastic, flippin' device ever. I want to build creation tools that people love to use. Or streaming from a DJI drone if they ever fix their RTMP implementation. Yes, exactly. Yes, exactly. Oh, RC2 also has HDMI output over USB-C. It does? Does it have UVC then? Because then, I mean, you can just... What? Jack, will you try this? Oh, wait. No, you have your new drone. Yeah. Dude, that would be really sick, because then you can just plug it in as a webcam. We tried when Jack was here. He has the DJI Osmo, a DJI Air 3 drone. And when he was here, we tried to stream with RTMP over to the Bella box, but the RTMP link just refused to work. I know it works with the Mini 3, because I have a couple of buddies that uses the Mini 3. But yeah, the RC2 controller something doesn't work. Yeah. Oh, you need one of those when you're done? Yeah, you see, they are really cool. It's gonna be cool. It's gonna be flipping cool, I think. Flipping cool. Chat. It's now been 2 hours of streaming and the phone has not overheated. I am calling that success. The battery is still at 80%, and that's just because it has stopped charging to thermal whatever and efficiency, and it probably thinks it's nighttime and it doesn't want to charge fully into the morning. I actually don't know why it's not at more than 80. 80 is just fine. It works. iPhone 15 Pro with a USB hub over USB-C with charging and wireless Rode Go 2 mic connected. Everything just flipping works. I'm amazed. Going directly to Twitch using Speedify. That's pretty wild. And you can set up like on-screen alerts and stuff. So if Siri were to use this app, this is, as you can see from the little logo, it's Streamlabs. If Siri were to use this app, her bit alerts would be in sync. That is pretty wild. So just pull up a phone and click start streaming. Very exciting stuff. Chat, it's been fun. The official, like trying to figure this out is now over. It's 1 a.m. and I'm not going to be soldering now in the middle of the night. But I'm super happy to say that this experiment about soldering to the pins, it's probably going to work. And when we have a moment, we're going to do it. Until then, shit, I just realized I have gutted the Jetson Nano case. In order to try this out, I stole the Wi-Fi chips that was... So if Siri tomorrow I want to be like IRL streaming and leaving the house, I need to build this system again. Sheesh, I didn't plan for that. Let's... I mean, honestly, I can just use the phone like we're doing right now. It works. It works. Yeah, don't need the bell box. It's gonna be fine. So, if you want high quality content, come back another day. Johannes is logging out. My brain has shut off all this thinking. I'm so excited. I really think we have come a long way tonight. All right. I'm kind of surprised how good the Mini 3 Mini 4 seems to be. It's not as smooth as the Air 3. The Air 3 is flipping amazing, Jack. It's like a super cool. Like the only thing you would miss, I imagine, with the Air 3 compared to say an Inspire, right, is the 2 operator thing, where one person can control a gimbal 360 degrees and the other person just flies the drone. That's like the only thing. And I mean, maybe the Inspire isn't even faster, right? The Air 3 is the fastest DJI drone, at least for ascend and descend, I think. Maybe the straight line speed is higher on the Inspire. I don't know. Yeah, I'm gonna have a shower and then I'm gonna go to bed. Thank you for joining today, and thank you for the new followers. That's been great. Coda and that good, and Toby who just found. Sorry, Toby said something about SRT-LA. Oh, I must check. Sorry, I read it and I didn't really pick up on it. He says, great news, spent the last hour coding an installer and manager for self-hosting SRT-LA on Ubuntu. One command? Are you flipping kidding me? Are you saying to me that the Raspberry Pi 4 that I ordered for an experiment with bonding that didn't really pan out the way I wanted it to, that this can be my own SRT-LA relay with one click? Why that is important, it's not that I don't want to pay Rational. I kind of do. I kind of probably will pay him anyway, because if he can get money, he will continue developing the whatever, the Bella box. He will keep making it better. So I'm fine with that. But what I want to try with a self-hosted relay is when I'm using 4G connection, a single one, not bonded, and I'm running a speed test to a Stockholm server versus a German server, Frankfurt in this case, I actually get about 10% better throughput to the Stockholm server. And you might say, well, 10%, who cares? Well, if you have 2 megabit or 1.8, that kind of matters. And that's per connection. If you have 2-3 connections, it compounds, right? So if I have this little thing with a self-hosted, which Toby, by the way, if you do, I would be grateful if you could send it, and I would love to try it. When I want to try them, when I am in Sweden, when I'm in my home, when I'm around, this area, do I get more speed to a self-hosted versus using BellaBox Cloud? Interesting. That's the test I want to do, which is why I've been keen on doing the self-hosted relay server. I must bid you all farewell. Thank you for watching, and I'll see you when I see you. 2 hours and 16 minutes. What a test. Bye. And Jack, we'll see each other tomorrow. Sleep well. Good night, Lars.